In this tutorial, we're going to be solving for one variable equations. Before we do that, let's refamiliarize ourselves with some terminology we'll be using. Now, each thing here, separated by a plus sign, is called a term. So I have three terms here. Now, this first term has a coefficient and a variable. The coefficient is any number in front of a variable, and the variable here would be our x's. A number that's by itself, that is not being multiplied by a variable, is called a constant. So we'll be using these terms of coefficients, variables, and constants. Now, in this first example, we're going to be solving for x. Now, when you're solving, the idea here is you're trying to get the variable on one side of the equal sign by itself. So everything else has to go to the other side. So let's start off by getting rid of either the 2/3 here or the 7. Now, if you remember what PEMDAS is, we're going to be solving in an order that's going to be the opposite of PEMDAS. So we're doing SADMAP. So that tells us the order in which we cancel things out. Now, of course, we do the opposite operation when we are canceling things out. So because we're multiplying by the 2/3 with the x and subtracting by the 7, SADMAP tells us that we're going to cancel out anything we're subtracting or adding. And because we're doing the opposite operation, we're going to add the 7 to both sides. This is going to leave us with a 2/3 x equals 12. Okay, now we need to get rid of the 2/3 x, or rather just the 2/3. We're multiplying it, so we want to do the opposite and divide by 2/3. So I'm going to do it to the left side. And remember, what you do to one side, you do to the other side of an equation. So that's going to leave me with x equals 18. And that's our answer for x. So x would have to be 18. Of course, you would check that by substituting that into the x here. So when you say 2/3 times 18 minus 7, it will indeed equal 5. If you're not comfortable with dividing both sides by 2/3, there is another way in which you could go about doing that. You could, instead of dividing by 2/3, because it is a fraction, you could multiply by its reciprocal. So I could multiply both sides by 3/2 if you prefer. So these cancel out. That would leave me with x equals 18 once again. So do whatever suits your taste. Now, in this next example, we have a variable on the left as well as the right side. So remember what I said, you have to get the variable by itself on one side of the equal sign. So in this case, I'm going to move the y to the left side. Now, you could move it to the right if you want. It doesn't really matter. But I'm going to go ahead and move it to the left because I feel like it. So I'm going to go ahead, and since this is a positive 13y, I'm going to subtract 13 from both sides. So I'm going to say minus 13y minus 13y, like so. Now, that's going to leave me with a negative 5y minus 16, which equals 9. Now I'm going to add 16 because of SADMAP. So this is just like, at this point, it's just like that last example. So we'll be left with negative 5y equals, and we'll say 27. My apologies, I mean 25. No one's immune to the almighty mistake. We try to catch them as we go along, if not beforehand. And now we're going to divide both sides by a negative 5. Now remember, a positive divided by a negative is going to leave us with a negative. So y is equal to negative 5 in this case. And there we've solved our variable. So feel free to review this problem over again if you need to see something over again. In this last example in this tutorial, we got a number of things going on. We have we have two variables on the left, we got a variable on the right, and there's a lot of things going on here. So I'm using this problem to help review a concept of called the distributive property. What we want to do here is, see, we have a bunch of terms to the left here and we have a number of terms to the right. We want to simplify these before we start solving. We want to, this is a mess, so I want to make this a little bit more clean and easier to work with. So I'm going to start off and I'm going to use this distributive property. So remember, that's when you have a number outside the parentheses and then you multiply it with everything inside those parentheses, and that's going to leave me with 8x minus 36, and then I'll just bring down the 5x, and I'm going to distribute this negative 3 to both terms there. So that's going to leave me with negative 30x, and then now here's where you have to be careful. You have a negative times a minus x. We could consider this like saying minus negative 3x, but that's really messy. We know that saying minus a negative make a positive, so that's just like saying plus 3x. Okay, so we could just simply say, oh, well, that's positive 3x. Now, going back to the left here, I'm going to say, well, what else can I simplify? I have an 8x and a 5x, so that's going to leave me with 13x minus 36 equals negative 30 plus 3x. Now you're saying, well, wait, Mr. Seitz, what did you do here on the left side? How did you say 13x? Well, remember, you can combine like terms. Like terms are terms that have the same variable and same exponents. So by having an x here on the 8 and the x here on the 5, I could add these two together. Okay, so that's going to leave me with 13x. Because the 36 has no x, I can't combine it with these. It's a different term. And there are no like terms on the right side, so I just leave those terms alone. Now we're at the same stage as the previous problem where we have a variable on either side. So now we can simply get the variable on one side. Again, I like to move it to the left side. You don't have to, but I'm going to subtract 3x on the left and right. What you do to one side, you do to the other. And that's going to leave me with 10x minus 36 equals negative 30. And then I'm going to add 36 to both sides, like so. And that's going to leave me with 10x equals 6. So in this last step, we have x equals 6/10, but we want to reduce that fraction as much as possible, so that's going to reduce to 3/5. So I'd box that in as my answer. So that concludes the review on solving one